Here are some quick notes on 5.3, solving log equations. So this first one right here, notice that you have the same base. So whenever you have a log on both sides and everything has been condensed, you can drop your logs. So we're going to say drop the logs. You can only do this if they have the same base. So you could go 3x equals 36. And then solve. X is 12. That's your answer. Number 2. So notice we have 3 logs here. That's too many on this side. So when you have 2 on one side, you need to condense to 1. Condense to a single log. Okay, so in order to do that, you have to write 1 log, log base 8. Now, subtraction means you're going to divide, so you're going to go 48 divided by x equals log base 8 of 6. Again, now we're back to how we were on example 1 there. Notice you have a log base 8 on both sides, so we can kind of just drop these and set 48 over x equal to 6. We're going to cross multiply. So 6x equals 48 and x equals 8. That's it. Solve and explain each step. Okay, so on this one, yes, you could do this on the calculator, but I don't want you to. I want you to solve and explain each step. So when you have something like this, you can take the log of each side or the natural log of each side. In calculus next year, they're going to do the natural log of each side, but in this one, I probably would do the log of each side since there's a factor of 10 here. So what I would do is I would take the log of each side. Now remember, log is base 10. So by doing this, we can use our calculator, that log key on our calculator. When you do this, because this is a binomial, make sure your binomials are bounded with parentheses. We can release this out front. Make sure it has parentheses around it, or you'll miss this problem. Then you have log 10 equals log 270. Now, this is base 10 of 10, so the property says that this is 1. So if you punch this in your calculator, it's 1. So what you really have is x minus 1 times 1, which is just x minus 1, equals log of 270. And then I would add 1 to the other side. So it's log 270 plus 1. Log 270 plus 1. So at this point, you would go ahead and punch this in your calculator. And you're going to press log right here, this key right here, log 270. And now make sure, if you don't close your parenthesis, you're going to miss this problem. If you do not close that parenthesis, you're going to get the wrong answer. And your answer is 3.4314, 4314. So 3.4314. And that's what x equals. This one. So in this one, do you want to get e by itself before you do anything? So I'm going to add 3. Then I'm going to divide by 5 and get it down to where it's just the base, e. Raised to an x plus 1 equals 3. So last time I did the log of each side. This time I'm taking the natural log of each side. The natural log, because there's an e involved. And then next year, Mr. Heelan will always take the natural log of each side for every problem. Like I did log last time, but he'll take natural log every time at both sides. Again, this is a binomial, so bring that out front. Bounded, that means in parentheses. So what is the natural log of e? Well, since that's base e and that's e, this is going to cancel. These are inverses. So this is just going to be a 1. So what you really have is x plus 1 times 1, which is x plus 1, equals natural log of 3. Subtract 1, you get natural log of 3 minus 1. So again, we're going to press the natural log key right here. Press natural log of 3, close your parentheses, minus 1 equals 0.90986. Okay, and 5. So look at this. It's a trinomial. We get a factor. I know that you guys love to factor, especially when there's an e involved, but it's not that hard. So what we're going to do is we're going to factor this, because we can't get, even if I add 5 to this side, I still have 2 terms that have e in it. So we need to get these e's separated. Okay, so we're going to do that by factoring. So this first one is going to be e to the x. If you multiplied e to the x and e to the x like this, you would add the exponents and you'd get 2 to the x. So e to the 2x is really e to the x, e to the x. Okay, that's how you separate e to the 2x. Now, what are factors of -5 that add up to -4? Did you say -5 and 1? You are right. Then take each factor and set it equal to 0. Add 5. And now we're going to take the natural log of each side. Bring the x out front. Now the natural log of e is just 1, so it's x equals whatever the natural log of 5 is. And the natural log of 5 is 1.6094. That's one of your answers. Now the other answer, subtract 1, take the natural log of each side. This is 1. Guess what? You can't take the natural log of -1. Let me show you why. You can't take the log of a 0 or negative. Think about the graph. Let me just show you the graph real quick. Remember, the natural log graph, the first point is 1, 0. And the next one is like 2.71. This is what a natural log graph looks like. So if I said, what's the natural log of -1 right here? There isn't anything over there. It's nothing. So this is going to be undefined, but let me show you what the calculator does. It's going to be undefined for that one. So you're going to do natural log of -1. Error. Okay? Can't do it. So only one answer for this one, and that's it. So let me just show you really quick if you would have graphed this. So press in second division e raised to the 2x. Okay, minus, use your right arrow, minus 4e raised to the x minus 5. Okay, I've got that in there. And I'm going to graph this on Zoom 6. I'm going to make sure I'm on Zoom 6. So basically, they want to know when it's equal to 0. It's equal to 0 right there. Isn't that a crazy graph? That's what the graph looks like. So if I wanted to see what that is, I could go second trace 0. And I think it looks like it's between 1 and 2. So my left bound guess right here, left bound guess is 1. Enter. Then it says right bound guess, and I think it's between 1 and 3. I'm just going to make it even broader. Between 1 and 3. Do you see how my 2 lines, it's between those 2 points? Press enter. And my 0 is 1.6094, which is what I had right there. Okay. Oh my gosh, I gotta do the back real quick. All right, so 6, simplify and solve. So on this one, we're going to divide by 2. Natural log of 3x equals 6. On this one, whenever you have a single log, you want to do a swoop. Single logs, think swoop. Single logs, think swoop. So this is a single log. So there's an e here. So if we swoop, you get e to the 6 equals 3x. Divide by 3, and x is e to the 6 divided by 3. Punch that in your calculator. E raised to the 6 divided by 3 is 134.4763. For 7, we're going to divide by 3 and get log x minus 4 equals 13/3. I'm not even going to change that to a decimal yet. Now what's the base here? The base is 10. So we're going to, again, this is a single log, so we're swooping. So we're going to go 10 raised to the 13/3 power equals x minus 4. Add 4. So x equals 10 to the 13/3 plus 4. So we're going to go 10 raised to the 13/3. Let's do parentheses. 13 divided by 3 plus 4. So it looks like that. Equals 21,548.3469. That's okay. Divide by 3. Yep. So this one's also a single log. Now this one's by itself. There's nothing out here to divide, so we're ready to go with this one. What's the base? The base is e, right? So swoop. E to the 7 equals the square root of x plus 2. Now, we need to square both sides to solve for x. Square both sides. So this is e to the 14th equals x plus 2. Subtract 2. So the e to the 14th minus 2 equals x. So e raised to the 14th minus 2 is, I feel like I did this problem. I'm going to do this another way to make sure I did this right. All right, so this is what I got. That's a crazy number. Let's look at this again. I feel like I didn't do this right, so I'm going to try this another way using our properties. So natural log, I'm going to write this as x plus 2 raised to the 1/2. Because that's the same thing as square root. Then that means I can bring this out front. 1/2 natural log of x plus 2 equals 7. How do you get rid of a 1/2? If you multiply both sides by 2, you can get natural log of x plus 2 equals 14. And then swoop, and you would have e to the 14th equals x plus 2. So your answer is e to the 14th minus 2. I'm going to see if that's the same answer. Oh, it is. Oh, okay, it is the same answer. Okay, so I'm right. That was just another way of doing it. And really quick, we have 2 logs on this side. So we are going to condense to a single log. So if you have 2 on one side, condense to a single log. And that's a minus, so we're dividing. Now, notice you have a single log. So now we're going to swoop. So 2 to the 1st equals x over x minus 1. Cross multiply. So 2 times x minus 1 equals x. 2x minus 2 equals x. Subtract 2x. And x is 2. Okay. I'll be with you in 1 second. I have one more problem to do on this video. Okay, now we have 3 logs. You can see this, but we can't drop a log until this one's down to 1. So we are condensing on this side. So it's x minus 1 over x plus 1. Okay, and then we can drop a log. Drop log. Those are the same. So we have x plus 5 equals x minus 1 times x plus 1. Now we're going to cross multiply, but we're going to have to FOIL these two.
Oh, you're doing it, actually.
Give me 1 second. So if you FOIL, you get 6x plus 5 equals x minus 1. Let's subtract an x and add a 1 to this side. Sorry, I'm going fast, but I have a class right now. This is 5x plus 6 equals 0. Just rewind it if I'm going too fast. X plus 3 and x plus 2 are my factors. And x equals negative 3 and x equals negative 2. But you can't take a log of a negative number, so these need to be plugged in. Plug in. You cannot take the log of a negative number. So if you plug this negative 3 in, this one's okay because negative 3 plus 5 is 2, so this is okay. But negative 3 minus 1 is a negative 4, so this is no good. And then a negative 2 also makes, so this has no answer. So if you would graph this on the calculator, right here, this on the left side, this on the right side, they would not intersect. So the answer is no. All right.